Yes, sir.
Okay. So we are discussing about the configurations. Okay, so configurations for our electrical power system in traction system and traction. Okay, so where it was discussed like that. Initially, in my last class, we are discussing about the DCEMU and ACEMU. Okay, first condition was there based on that overhead connection. It is in DC. Okay, and return path is there that a wheel. Okay, so it is DC that was discussed in last class. Then we are discussing about that AC. Okay, so ACEMU means normally where we are traveling from one place to another place. So both the cases return path will be your wheel. Okay, so in case of ACEMU, what you are doing, so pantograph is there first. Okay, pento is touching over there, and then circuit breaker. Okay, from the circuit breaker you can disconnect your system. Then transformer is there, stepping down that voltage. It is normally 25 kV. Okay, so stepping down that voltage, then rectifier is there. Okay, so from the rectifier, what you will do, make it DC. Okay, then inverter is there for in traction motor drives. Okay, induction motor you are using from rectifier to inverter, so you can use the vector control. Okay, so vector control for doing the speed control of your induction motor. Okay, that DC. Again, one inverter is there for your internal power supply. Internal power supply means for internal electrifications as well as your defined relay measuring instrument operations. Okay, for that one transformer is there. The transformer having one AC output. By that AC output you are utilize that AC for that internal electrifications. Another one is there, that AC/DC rectifier is there for the charging stations or of your battery charging. Okay, charging of your batteries. Okay, that traction batteries. Okay, so from here, what you will do, one that capacitors are there for smoothing, that there is a ripple. Both the cases you can see that rectifier is there. So ripple is there. Okay, so you can nullify the ripple. Okay, by using that capacitor man. Okay, so you can smooth out that ripple one. Okay, so here it is a DC path. So from the figure, what you can see, it is your AC mu configuration. Single phase AC supply is there. Okay, is collected from overhead conductor. Okay, overhead conductor means this one is your overhead conductor through the pantograph. Okay, and given the step down transformer. Okay, so step down transformer is there for 25 kV to how much voltage level. So normally 415 volt we are stepping down. Okay, the output of the transformer converted to the DC by the rectifier. Okay, so here you can see the rectifier one. Okay, you are converting the DC and given inverter. Figure shows the general block diagram. Okay, general block diagram for electronic power and auxiliary service of the AC unit. So AC output you are getting as well as auxiliary service means that internal so fan, light. Okay, so internal electricity, everything is there for the auxiliary operations. Function remaining component the same as the DCEMU. Rest of the things are the same. So in case of DCEMU, direct DC are there, so there is no transformer. Okay, so that transformer is absent in case of DCEMU. Okay, but here you are, here no transformer is there. Rest of the portion is same. Okay, but here you are using one transformer. Okay, for that conversions. Okay, so metro systems. So metro system means that I was telling about that in India, so different metro services are there for urban, inside of the urban, okay, urban suburban services also be there. Some metro cities, okay, you can see that not like only normal cities. For metro cities, so electrical transportations are very much famous. Okay, why that is famous? Basically to avoiding the traffic system. Okay, traffic jam will be there. Okay, so avoiding all those things, you are using some regularized transportation, okay, electrical transportations for reducing the losses. Sorry, reducing the pollutions. Okay, reducing the pollutions and fast reaching of your destinations. Okay, so here you can see some of the examples at the metro rail coming from metropolitan city. That's why metros are telling like that. So oldest one is Kolkata Metro 1984. So it is operated in DC. Okay, if you go there, so 750 volt DC. Third rail is there just beside of your railway track. One another additional rail is there. There is some covering is there. So some extension is directly coming from your metro rail to connecting over that third rail. Okay, all the time it is touching from there. Okay, and collecting the power from that one. So number of station, it is written 24, but it is not 24. It is more than 24. Now it is spreading some other side area also. Side area means you can say like that greater Kolkata side thing. Okay, so now it is not 24. It is near about 50 stations. Okay. So Delhi Metro is there. Okay, that is 160. I think that number is not also correct. Okay, that is more than 200. So Kolkata, so Delhi Metro having different line. Okay, so blue, magenta, then yellow. Okay, so red. Another few 6, 7 routes are there. Okay. So 6, 7 routes are there. Okay, recent one is I think magenta. Okay, so individual route having more than 20, 24. Okay, station. So 160 is not the correct one. So it is your 25 kV AC. Okay, so it's a AC metro. You can see over there. And one thing is that in Kolkata metro, what happened? It's going to underground. Okay, so it's not like that. Some of the routes are not underground, but most of the portions right now that extensions are there, they are not almost are not underground. But few of the extensions are underground. Below Ganges there is some line. Okay, so Delhi Metro. Okay, Delhi Metro magenta line is there, that is underground. Okay, not all the lines. Magenta line is underground and other lines are there. If you go for the Noida side, so they are not underground one. Okay, some of the portions are underground, but most recent one is underground, that magenta one, but the rest of the things are not underground. Okay, so you can see it's a 25 kV AC. So there is a difference. Why underground? Why 75 volt DC and why 25 kV AC? So that's the difference. Okay, if it is underground, so 25 kV means it should be overhead line. Okay, why overhead line? So there is some idea. Okay, 25 kV means 25,000 volt and 750 volt. Okay, both are different. So if you make it 25 kV in underground configuration, so that means what? You are collecting the power from through the pentro. Okay, so additional height. Okay, additional height you have to provide above of your metro rail. So that additional height may cost more cost, may cost for most costing. Okay, that is not cost efficient. So what you need to do, you have to make hard line. Okay, for cost minimizations. But problem is that in the third line, if it is 25 kV, so what is your ground potential? It is 0. Okay, so difference between 25 kV to 0, it's a huge potential difference instead of 750 volt to 0 volt. I hope all of you are getting my point. So that's why if it is underground service, so normally normal consideration is that 750 volt. So insulation side will be less and you can give the proper insulations and in cost efficient manner. That's the motivations. Okay, whatever we are doing, some idea is there. Okay, why it is 25 kV, but 25 kV means the loss, transmission loss will be less. Okay, and directly you can collect it from traction substation. One substation is there that is known as traction substation. You can see the specifications for railway systems, okay, that voltage rating specifications and other measuring instrument specifications are quite different, okay, normal conventional power system equipments, okay. So why? Basically for preventing the thief. Okay, so some of the person. So what specifications they are using? So railway equipment, suppose transformer. The transformer specification is not like the normal transformer specification. So you can see anybody cannot steal it. If they steal it, so they cannot sell it in direct manner. Okay, so they can damage it and after that they can sell it. That's different issue. So both the cases they are separating, and railway traction system on traction substation is there. Okay, normally if you travel from one place to another place, you can see that your railway track, some substations are there, that is 132 kV slash 25 kV. Okay, so that is known as traction substation. What is your traction substations? So you are giving the supply to the feeder. Okay, feeder means you have, so suppose you are having two lines are there. So after some duration, you have to give the power to that one. Okay, to that lines, that catenary and contacts are there. Okay, so you have to give that power supply to the catenary wire, not contact wire. So contact wire is directly connected through the dropper with that catenary. Okay, so in the traction substation, some special type of transformer you can observe. The transformer is known as that Scott connections. Transformer having Scott connection. It's a 3-phase to 2-phase configuration is there. Okay, special type of transformer. Okay, so that's Scott connection. So you will get 2-phase. So two lines are there, one upline and another one is downline. So both the cases directly give that power supply to both the lines. Okay, that's the motivations for using the Scott connections. Okay. So now other metros are there like in Bangalore. Okay, so you can see both are in underground, so they are having less voltage. Okay, 750 volt, 750 volt. Okay, those are not in. Then Mumbai metro also be there. I don't see Mumbai metro. Basically, I don't go Mumbai till now, so I don't see. Is it? I think that also in monorail type of thing is means it's not the underground one, but I don't know. I seen the Delhi Metro, Kolkata Metro, both I can see, but other metro I didn't see. Okay, so normally 25 kV means it is, you can see that most of the portions it will be just above of your ground. Okay, not be in underground one. Okay, so you can see other metro different. Now it is very much familiar. Okay, so what is there? Metro system is the underground railway system. Okay, now all are not underground. It's run in electric power. The metro system is the best suited for the density populated city where the local transportation is the crucial. Okay, means difficult to that one. The signaling activity are to be tightly coordinated. The heroic distance is also crucial if more than one train works on the single track. Okay, distance travel to the metro is comparatively less as compared to the normal train. Means like that after 2 minutes, 3 minutes, the station will be like that. Money is just like a bus stop. Okay, just like a bus stop. Okay, it means the transport within the metropolitan city. Okay, the distance between two stop also very less. When metro service means less than your urban service. Okay, urban means there is minimum 5 kilometer, but but a metro 5 kilometer not like that. It's like a bus stop. Okay, the technology used in the comparatively superior compared to normal train. The metro system mainly used for the by the people for the transport, not use the good carriers. Okay. So this on the normal configure features. So traction systems, like that. So how much efficiency we are talking about different types of traction system, steam locomotive. Okay. So it is efficiency 5 to 7%, gas turbine electric locomotive 10%. Okay, so diesel electric locomotive 25% to 30%, electric locomotive thermal power plant 35 4 to 36%, locomotive hydroelectric power plant. Okay, so 40 to 42%. Now we are using totally electric action, that is more than 80%. Okay, their efficiency. Okay, so systems of the track electrification. So DC system, single phase AC system, three phase AC system, the composite system. Single phase and three phase system or the condo systems is known as. Okay, normally we are using single phase AC. Okay, that two phase configurations are there. Okay, three phase to two phase, one phase is for one line, another phase is for another line. Okay, three phase system normally we are not using. Okay, so single phase DC system. Okay. So for the DC system, what is our configuration? So what is our basic here? Operating voltage value is 600 volt. Okay, 1500 to 3000 voltage for spacing between means two station differences are telling about that. So 5 to means suburban. This is for R1 service. So 5 to 3 kilometer to stoppage in between. Another one is 30 to 40 kilometer. Okay, so it is your main line service. Another one is your trolley bus, means normal suburban system. Okay, so where we are giving, so three phase AC is there, then 33 kV to 132 kV lines. Okay, so normally from the substation you are getting that connections directly from generating substations. Okay, 132 kV. So from 132 kV to you are converting to that traction substations. Okay, so 25 kV. Then you are using the 25 kV to as per your requirement. Okay, so 600 volt to 3000 volt DC based on your for locomotive their voltage level is different, means for mainline service. Okay, normally 3000 to 5000 volt you are using. Sorry, and normal EMU small normal EMU we are using 600 to 750 volt. Okay, so it is their operating voltage is 600 volt to 750 volt for normal line. Okay, urban and suburban. Okay, suburban railway. Okay, urban and suburban railway. For mainline service it is 1500 volt to 3000 volt for mainline service. Okay, so distribution system consists of one contact wire in case of tramway, or two contact wire in case of trolley bus. Okay, and the spacing between two suburbs depends upon the operating voltage and traffic density of the routes. Okay, it depends. Okay. Advantages. What are the important advantages over there? DC series motor is the better speed torque characteristics for smooth speed control that you are using. High starting torque, another benefit. Low maintenance cost, small weight per kilowatt output. So as per kilowatt output, the weight is less. Better speed control method. Okay, and efficient braking system. Braking system also efficient. Okay. What are the disadvantages? Disadvantages are also there. This system has high cost of substation due to converting equipments. Okay, high cost. Okay, for conversions that multiple stage conversions are there that you are using different types of power converters. So definitely due to conversions, energy losses will be there. Okay, more number of substations required as the space is shorter distance. Okay, more number of substations means more costing. Installation cost means more, and side by side you have to provide the booster transformer. Okay, or boosting transformer. Okay, so that maintaining that voltage profile fixer. Okay. Additional equipments like negative boosters also required for the maintain the run voltage within the specific limit. So otherwise what happen? So there is a huge load. Okay, so dropping voltage dropping will be there. So you have to install the booster transformer for some given distance. Okay, if you are not giving the booster transformer, so that you are using that contact wire. Okay, and that catenary wire for that providing the electrical energy to your locomotive, that where so voltage will be dipping. Basically it's a huge load. Okay, huge load means huge current. Okay, huge current means what happened, power is fixed. So huge current is drawing means current is increasing, load is more means current is increasing, so making power is fixed, so voltage will be deep. That's why booster transformer is required for regular interval for maintaining that voltage value fixed. Okay, so in single phase AC system, okay, AC series motor are used for getting necessary motive power. Okay, the voltage employed for distribution network, it is 15 to 25 kV. Okay, 15 to 25 kV or 25 and frequencies around 25 hertz, which is stepped down on the locomotive to low voltage suitable supplying to the single AC series motor. Okay, these all are there. Okay, so what are the operations? Locomotive. Okay, then you are stepping down the voltage. So you are stepping down from 25 kV to that given value. AC series motor is there. Okay, so what is there? Power grid substations are there that I am telling, that reducing the power, stepping down the power, three phase 50 hertz to 33 kV to 132 kV line. So frequency converting unit. So then high voltage at low frequency. Okay, when a high voltage is 25 kV 50 hertz, low frequency means in single wire. Okay, so these are the basic configurations. Okay, the spacing between substations are normally 50 to 80 kilometer. That we are talking about traction substations, the distance between two substations. The change of supply frequency become necessary because the better in performance, okay, improve its computations properties, power factor and efficiency, reduces the line reactance, hence the voltage drop. Okay, this some possibilities are there. So AC single phase system are invariantly and adapted for the mainline service. That is very common. Okay, single phase AC service, but three phase service also you can be used. But problem is the balancing problem. Okay, you can also use the three phase system directly. The pantograph can collect the power from the pantograph directly from here. But main issue is that for three phase means there is a huge chances for unbalancing. Okay, unbalancing conditions is there means some unnecessary unbalancing problem is there means there is a unnecessary current flow inside of the in between two phases. Okay, that is not acceptable. Any situations false are observed, so zero sequence component may cause some other issues. Okay, so that's why it's a quite problem with dealing with the AC system. Okay, for the traction purpose. Okay, for directly collecting the power from that is three phase system. Okay, that's the issue. Otherwise, the output voltage from the three phase definitely more than of your single phase voltage. Okay, everything you will getting benefited using three phase, but problem is that it's for unbalancing and it having some severe effect. Okay, that's why you have to, we are not using the three phase system for the traction purpose. Okay, the three phase induction motor operated 300 to 3600 voltage with low frequency are employed for getting the required motive power. Okay, the three phase induction motor is their simple, robust in construction, high operating efficiency, automatic regenerative braking without requiring any additional equipment. Okay, so regeneration will also be there. Okay, without additional equipment. But drawback is the starting torque. Okay, starting torque is their high starting current, inrush current for induction motor very high. Starting torque is comparatively less than your DC series motor. Two overhead connect wires. So definitely overhead. So three wires are there, so they difficult na to accommodate. So for making the balancing, if you want to balancing them, so three different configuration connections is required. But in other cases, it is benefit efficient over your single phase system. Okay, the condo system, single phase to three phase conversions. Okay, then you are using. Okay, or vice versa. The system, the single phase high voltage in 25 kV, it's a normal supply frequency used to distribute the power. But you are getting the 25 kV from where? Three phase system. Okay. So that condo system we are talking is a traction substation. So end of the day, what we are using? The condo system we are using. Okay. So first we are having power grid, power from the grid substation, three phase 50 hertz, 33 kV or on 33 kV, then traction substation. We are converting in two phase. It is written single phase, but single phase given for individual line. Okay, means suppose upline you are giving one phase, downline you are giving another phase. So 50 hertz, 25 kilovolt. Okay, it is your locomotive to three-phase converter and three-phase induction motor. The locomotive which carries a phase converter which converts the single phase AC to three-phase AC. Okay. The three-phase power is then feed to three-phase induction motor for getting the necessary motive force. Definitely simple thing. In the system have one contact wire or the overhead system, and it's a single phase. Okay, but you are getting the output from three-phase system. So average voltage definitely more than high. I mean, normally is more than your single phase one. And disadvantage for the three-phase AC system. This system is adopted in Hungary 1932. Now it is very much popular in our conventional system. Then single phase to DC system, single phase AC to DC system. So what is there? So you are getting the substations. Okay, power from the grid substation. Three-phase 50 hertz system is there, 33 kV to 133 kV lines. Traction substations, normally you are using single phase 50 hertz. So locomotives are there, they will directly collected the single phase AC 50 hertz. Then what they are doing? Step down transformer. Okay, then AC/DC converters, rectification is there, just like your AC locomotive. Okay, that we are discussing about. It's a 5, 6 slides before. Okay, same system. Okay, AC/DC converter, DC series motor for the traction purpose. Okay, so based on the travel distance, the voltage rating of the motor also change. Okay, so for our normal suburban and urban service, we are using how much voltage level? Okay, so that we are using 600 voltage. And the same thing for mainline service, we are going for more than 5000 voltage. Okay, so what is there? More, sorry, 1500 to 5000. So how much is there? So it is written that AC 25 kV normal frequency we are considering and we are using them for overhead distribution. And the AC locomotive, okay, AC locomotive series transformers are using for step down the high input voltage and rectifying the equipment to convert AC into DC. Okay. This system is adopted in India for track electrification. So okay, the system becomes the most popular because of the salient advantages over the other systems, specifically for the DC system. Okay, and you can see that how much voltage. So 50 to 80 kilometers we are using the distance for longer distance. Okay, and the substations are almost 12 to 30 kilometer away in case of 3000 volt to 5000 3000 volt system, and 5 to 12 distance. Okay, the line current given the demand of the power reduce the high system voltage. Okay, so these all are the very basic concepts. Okay, for our traction systems. Okay, for supply, power supply of the traction system. So comparison of DC and AC system. Okay, DC and AC system for railway electrification from point of view of the main line and suburban lines railway services. Okay, what are these differences? For suburban service, essential requirement of the suburban service is rapid acceleration and retardation, means decelerations. Okay, right, due to the frequent starting and stoppage. Okay, motor performance should not affected by the voltage fluctuations. There is a chances for the voltage fluctuations, means lot of trains are running in the same track. Okay, so they are taking huge loads. Okay, still you are providing that regenerative power, but the chances are there. Less chances of interface of the telecommunications line running along the track. Okay. And mainline services, what are the most features? Important thing, higher maximum speed, that is VM, minimum cost to track electrifications. Okay, so it's there. And 25 kV single phase AC system is preferred. Okay, and 25 kV overhead system is there, reducing the conductor sections and hence simplify the structures. Higher spacing of the substations reduces number of substation, increasing the feasibility of the selecting cheaper. Okay. Land maintenance cost also been less, and equipment AC system efficient and cheap equipment you are able to use for it. Then there's a comparison between the DC and AC tractions. Okay, what are the comparison? You are using DC series motor. In motor point of view, you are using AC series motor. Performance is the good performance and not good as used for the DC traction. So starting torque is definitely more, it is less. Speed control is better, motor is limited. Okay, beta means limited for that operations but versatile, wide range of speed control. Means you can vary you can make the frequency constant as well as variation of the frequency. Here you can vary only after the only base speed, after that field weakening method. So these are versatile variations. Interface, DC system calls the less interface with the communication line. That it will process the more interface with the communication line. Overhead distributions, heavier and more costly comparatively your AC, and lighter and less costly. Why lighter? Due to that skin effect. Okay, so skin effect means you can make the conductor more of the process hollow in nature. Okay, substations. The number of substation required given track distance of DC traction is more. The number of substations required in AC traction is less. Weight of CU copper definitely more. Per tank kilometer is more. Per track kilometer is more. Weight of copper required per track kilometer is less. Why? Basically skin effect. Okay, applications. Okay, term applications is term weight trolleybus mainline sites. Okay, these all are the very basics comparison of that tractions. Okay, then current collector for the overhead line. Okay, current collectors for the overhead line means you are using pantograph. Okay, for DC, AC, both the cases you can use that. It having some arms, pantograph having two arms. Okay, one bow type things are there that can directly collecting from the power from your overhead line. Okay, then there is some comparisons. Differences. One is trolley collector. Okay, another one is that bow collector. Trolley collector means if you see the tram line. Okay, tram. What they are using? They are using some wheel shape of thing. Okay, so long on a long bar is there. Okay, just top of the bar, small wheel is there. I think if you see the wheel, okay, so pulley system. Okay, so if you see the wheel, okay, wheel actually not wheel. So if you want to collect the water from the wheel, so you are using the pulley. Okay, so trolley collector means it's just like a one round shape pulley is there with a long bar. Okay, so bar you are connecting the wire. Okay, connecting the bar where that wire is holding to that bar. Okay, so sorry, bar is holding the wire. Okay, and you are connecting one wheel, small wheel type pulley. Okay, so from that pulley, it's a wheel shape thing. Okay, that is touching with your overhead contact wire and collecting the current. Okay, that is trolley collector. Okay, but that high speed operation you cannot use. High speed means if that if that if that transportations having more than 50 kilometer, more than 25 to 30 kilometer per hour speed, so it cannot able to collect proper manner of the current. Basically huge flashing will be there. Okay, so it cannot able to proper collect the power such fast manner. That's why you have to use some bow collector. In bow collector you can see bow shape thing is there. It's your contact wire. Okay, one bow is there and it is your bow pole. Okay, this is vehicle roof. So both the cases for high speed operation directly it can touching over them and it can collect. Okay, that is bow collector. Both the difference I think you are able to understand. And it is your pantograph. Okay, in case of pantograph what happened? Pantograph it's a it's look like a bow. Okay, it's look like a bow, but bow don't having any spring type of thing. Okay, but what happened? So if you want to travel very fast, okay, so there is a jerking of your vehicle. Okay, so jerking will be there, will just above of the railway track. So then what happened? The bow tip, okay, the bow tip and that contact wire, okay. So over it, so contact where there is a gapping. Okay, for very fast operations. So gapping may cause for what? There is a flashing in between the contact wire and your bow tip. Okay. So collecting the power from your system or current. Okay. So to reducing that problem, what you will do? You are using some spring contact. Okay. So spring contact is there. So that is fixing up. Okay, that is directly fixing up that value. Okay, and you are not able to fixing up that amount of value. So you are so for any jerking, what happened? That pantograph always touching with your contact wire. Okay, so that's the difference between three things. One is trolley, next one is bow, and third one is pantograph. Pantograph, the spring is there. It's a Z shape of thing. Okay, Z shape or angle shape. So in between that force, huge force is given. So fix up the panto. Okay. So that's the way you are able to get, and their pressure is very much high. So it's from 5 to 15 kg. Okay, and to fixing up that where you have to give some additional tension with the pole. Okay, you can see if you travel from the train, so you can see just below the some after traveling some of the distance, you can see some drum shape huge weights are given. Okay, additional tensions are given to your catenary wire. Okay, for make it fixed. Okay, so make it fixed and maintaining the tension. Otherwise, the pinto having huge force. Okay, the force towards upward, and it cannot be if you are not fixing up the pressure. So pinto can break the line. Okay, so break that wire. So that's why you have to maintain the tension. Okay, these are the very simple point I have discussed. Okay, so more or less I have covered the traction portions. Okay, so I can also suggest all of you. Okay, so please complete that module. Okay, so please complete that module and submit your classwork as soon as possible. Okay, so tractions portions may be completed. Okay, and after that, what happened? After that, we can start for uh, after that we can start from new module. Okay, so new thing we can start. Okay, so some of the portions most of the portions I have covered. Okay, so if you have any confusions, okay, if you have any confusions, any queries, you can ask me. Okay, so I have most of the portions I have covered. Okay, so our next our next target is that illuminations. Okay, so we'll start the illuminations after the, so more or less it is completed, so we can start the illuminations. Okay, so any queries from your end? Is there any query?
Sir, what about mid-term
Hello.
syllabus and pattern?
Mid-sem syllabus, the traction will be there, and next week I will start another module. Okay, so that some of the portions will be there. Okay, so I am suggesting all of you please practice some numerical problems based on the tractions. Okay, so some numerical problem will come. Okay, so that is one suggestions. Next I will start that illumination. Some of the portions of the illuminations also come. Okay, your sim will be starting on 21st. Okay, so you are having another 10-12 days time, 10 days time in your hand. Okay, and I am suggesting all of you please submit the traction note by Monday. Okay, so and also suggesting that please I want to see that all of you please solve some numerical problem, okay, to your fair copy, okay, that you are going to submit in my submit by Monday. Okay, today is Friday, so we are having 2-3 days in your hand. Okay, so you can complete it and submit it by coming Monday. Okay, so from Monday we can start some new module. Okay, some new module, new theory we can start, and up to how much I have covered on my next week. So that will be the syllabus for our mid-sem. In mid-sem, I am just telling you some important instructions that for mid-sem there will be two parts. Okay, one will be the MCQ part. Okay, another some portions will be for descriptive question answer part. Okay, so for that MCQ part, that there are that for MCQ you have to upload. Okay, so you have to upload the uh, justifications. Okay, so you all of you please use white color A4 size paper. Okay, so no ruled paper will be acceptable. Okay, for the exam you have to use some A4 size paper, A4 size white color paper. No copy and means no khata, like that thing is not acceptable. Okay, so only white color paper, and you must, all of you must write down your name and roll number. Okay, in that your exam paper. So exam having two part, one MCQ part, 50% MCQ. It's not exactly 50%. So based on that, no, normally we are considering 50% MCQ, 50% descriptive. Okay. So for the 50% MCQ, so it may be 1 marks question, 0.5 mark question, 2 marks question. Okay, mixing up all those things. Okay, so based on the question, you have to solve the answer in that white color page, A4 size page. Okay, and after completions of your submission of your MCQ, so you have to upload the answer script. Okay, then descriptive type of question will start. For the descriptive type of question, again some white color A4 size paper, you will solve it. Okay, and after solving, you have to scan that paper, okay, in PDF. Then again you have to upload it. So everything will be given. Okay, I'll provide you that one. So if possible next week I can take one class test. Okay, so somehow traction portions may be practice. Okay, so I'm planning to take some class test. Okay, first complete it Monday, so I'm trying to take it on class test on Tuesday, but this is not final one. Okay, I'm not finalize it, so I will inform on my Monday class. Okay, but you people keep it in mind that coming Tuesday I will take one exam. Okay, class test. Okay, so that's some suggestions about your mid-sem. And for the mid-sem question will be normal questions, not so much hard, not so much easy. Okay, so normal question will be there. Some theory will be there, some numerical. You have to give more thrust on numerical based on the traction portion. Basically, that subject, whatever subject's utilization, it's an informative subject. So you can say like that 50-50. Okay, maybe 50% numerical, 50% theory may be there. Like in other courses, what happened? More than 70% are numerical, 30% theory. But in utilizations around 50-50 you can consider 50% theoretical question, 50% numerical. Theoretical means not like direct writing the statement and other things. Just a minute. So 50-50 you can consider. Okay, so and theoretical question means it's not like that stating the theorem like that. No, it's not like that. Some analytical question. There is a scope for getting money. There is a good scope for getting marks. Okay, you know that the pattern of my question paper. So this is not new. I'm not. My pattern is also familiar. All of you are familiar with my question patterns. Okay, it's not so much complicated, but simple like that thing. But you should maintain one thing that thing I am giving more trust, that you have to maintain the transparency. Suppose what happened, some of the question paper, I just saw some other students. So please do not share your answer with your friends. Okay, so if you are doing the same thing, it can be, I can see all those things. Okay, which is not done properly. Okay, so and that's why justification, so it is very important. Whatever you are writing, you have to give the proper justifications. If you don't mention the justifications, so marks will not be awarded. Okay, so suppose 50% marks will be awarded. Not total marks will be reduced, not like that. 50% marks will be awarded. Suppose MCQ paper is there, 2 marks question, so you are not writing the justifications. So not total marks will be 50% marks will be deducted. Okay, so that's why make it quite when you are preparing it, make it quite serious manner. Okay, so you people please submit that pending fair copy with with numerical problems by coming Monday. Okay, so maybe Tuesday I will take exam, that I will declare on my Monday. Okay, so keep in your mind that Tuesday maybe one exam will be there. Okay, so please practice, start practicing, especially that traction problem. Traction problem means DC motor problem. Okay, from Thereja book, lot of problems are there. Basically utilizations also having, I'm telling about different utilization book. Okay, you start practicing. Okay, if you have any doubt you can ask me, but start practicing. Simple numerical problem will be there, not so much complicated, but simple thing, but numerical problem will be there, that I can assure you. Okay, all of you getting my point?
Yes, yes, sir.
Yes. Okay, very good. Okay, so if you are having any other queries, please let me know. Okay, but start practicing.